Hey there, everybody. Today we're going to talk about segments that are in the coordinate plane, and we're going to find the distance between points, or the length of the segments, and we're also going to find the coordinates of midpoints of those segments. So just a real quick reminder of what coordinates are. When we put a point in the coordinate plane, like point A or point B, each of those points has coordinates. They have x coordinates and y coordinates. So you would say that A is at -4, 5. And as a refresher, the -4 represents an x coordinate and the 5 represents a y coordinate. B is at 3, -3. 3 is the x coordinate and -3 is the y coordinate. So what we're going to do is we're going to find how far apart points like that are, so the distance between them. And what we could also say is if we were to draw a segment between those 2 points, we could figure out how long that segment is in the coordinate plane. So the distance between 2 points is just like finding out the length of a segment. So we have a formula for that. You should be putting this formula in the flipbook portion of your notes. The formula is this d equals. I put these coordinates up here for a reason. So I had on the previous slide 2 coordinates, A and B, and they each had an x and a y. So when I look at my distance formula, I see x2, x1, y2, y1. These 2's and 1's are just sort of like last names of the x-coordinate. They're the last names of the y-coordinate. It's so that we don't have 2 y's and we don't know which one is which. So the 2 points that we get, and we want to find the distance between them, they're each going to have an x and a y. So we would find the x of 1 and plug it into the formula. Sorry. Find the x of 2, plug it in. Find the y of one of the points, plug it in, and then the other y. So it's just kind of plugging in information into this formula. And this is a formula you're going to have to memorize, but if you write it down every time you do a distance problem, you'll remember it pretty quickly. So I've written the formula again. I'm going to find the distance between points E and F. That's the same as finding the length of segment EF. So I recommend writing underneath one of the points x1, y1, and right underneath the other one x2, y2. So now all I have to do is plug the number into the appropriate spot. So I'm calling 7 x1. So 7 will go here. I'm calling 2 x2. That goes there. Calling 5 y1. That goes there. Calling -4 y2, and I'll plug it in there. So when I plug those values in, it looks a little something like this. Now I can simplify inside the parentheses. Now here's a really important thing. When I square a negative number, the answer should be positive. So I get positive 25 and positive 81. I'll add those 2 numbers together. And then I'm good with a decimal. We'll round to the nearest tenth. The square root of 106 is close to 10.3. So we'll do another one together, and I'm going to do the same process. You see that I have the formula again, so you should write the formula again and get used to that. I'm going to name C. Point C is going to have my x1, y1. Point D is going to have my x2, y2. And now I just plug in the numbers into the appropriate spot in the formula. Notice my x1 was negative, and then there's a minus in the formula, so I put that -2 in parentheses. So I'm careful when I simplify, because -5 minus -2 gives me -3. Remember again that when you square a negative number, it becomes positive. So when you square -3, you get +9. 6 squared is 36. Add those together. And you can use your calculator. The calculator in your phone will work. If you have an iPhone, you can turn it sideways to use the square root function. And the square root of 45 is close to 6.7. So just as a reminder, remember to pause so you can write this down before you listen, or listen and then write it down, whatever works for you. So go ahead and pause the video right here and find the distance between points A and B. So I'll keep recommending that you name one point x1, y1, name the other one x2, y2, so it helps you plug in the numbers in the right spots. Put my parentheses around -9 so I don't mess up that operation. Simplify. Now I square, making sure that -7 squared gives me +49. And I get that the distance between A and B, or the length of segment AB, is close to 8.1. The other thing we're going to do is we're going to find the midpoint of a segment. So we've already talked about midpoint. The midpoint's right in the middle of the two endpoints, and it creates two congruent smaller segments. Well, we're going to find the coordinates for a midpoint if we have 2 points in the coordinate plane. So I have 2 points, x1, y1, x2, y2, and I'm looking to find a point. So I need coordinates again. So when I find a midpoint, my answer is going to be in parentheses. I'm going to have an x coordinate for the midpoint and a y coordinate for the midpoint. So that's why I wrote midpoint. My answer is going to be a coordinate. It's going to be a point. So to find the x value, the x coordinate of the midpoint, I use this formula. I just take and I plug my x2 in there, plug my x1 in here, add, divide by 2, and the result goes into that final answer. Do the same thing with my y's, my y2, my y1. I add and divide by 2. My answer goes there. And when I'm done, this is my midpoint. So let's do a few of those. I want to find the midpoint of segment EF. So I'm going to label one point x1, y1, the other one x2, y2. And now I can just plug in the numbers where they belong in these two equations. So I'll go ahead and find the x value of the midpoint first. I plug in x2 and x1. I add 2 plus 7, and I'll divide 9 by 2 and get 4.5. I'll do the same thing to find the y value. Plug in y2 and y1, which are -4 and 5. Simplify, and it's 0.5. So I'm not done yet. My final answer has to be in parentheses like the coordinates of a point. So my final midpoint is 4.5, comma, 0.5. Another way to write that would be to use fractions. So I could write 4.5 and 1/2. I'm fine with both of these. You might like decimals better. You might like these fractions better. Whatever you think is most visually appealing. They represent the same location on the coordinate plane. And this point will be right in the middle of the segment EF. So I'll do one more with you. I'm going to find the midpoint of segment CD. I'm labeling my x1, y1, x2, y2. I'm going to plug these numbers into these two equations. So I'm plugging in x2 and x1. I'm doing some simplifying, and I get the x coordinate of the midpoint to be negative 3.5. So the same thing with y2 and y1. I get the y coordinate of the midpoint to be 4. So remember, I'm not done. This is a lot of good work, but we got to go plug back in and say that our midpoint is at negative 3.5, 4. You might also say that it's at negative 3.5, 4. So again, this midpoint, this coordinate will be on the segment CD, and it will be right in the middle of C and D. So if you wanted to, you could graph that segment and graph the midpoint and check that that's true. So go ahead and pause here and find the midpoint of So as I recommended, you label one x1, y1, the other one x2, y2. And we're going to go ahead and plug in. When I do that and simplify, you might have left it as 1/2, that's fine. I get the x coordinate, and now I'll get the y coordinate, which is negative 7. So I'm not done yet. I'll go plug that back into the parentheses. My midpoint is 0.5, negative 7. Or I could say it's 1/2, negative 7. So this point is right between A and B. It's on segment AB. It is the midpoint of segment AB. So again, 2 you-dos. Make sure you submit these to me. I want you to find the distance between points R and S. So just give me a number. You can round to 1 decimal place if necessary. And then find the midpoint of RS. So make sure you plug in using parentheses and a comma. Don't worry about putting any spaces. So make sure you use parentheses and a comma between the X and the Y. And if you have questions, please ask me in class.